In this video, we'll show how to find local maxes and mins of a function F when given the graph of its derivative f prime. Let's start with an example. Here's a function. It's going to be the graph of the derivative, not the function itself, but its graph, the graph of its derivative. So what do we do to find the local maxes and mins when given this graph? The key thing to remember is that local maxes and mins satisfy f prime equals 0. They're critical points. Well, in terms of the graph, what points are those? Those are the places where the graph meets the x-axis. So these are going to be our possible candidates for local maxes and mins. Now, the derivative itself is negative up until this point, then it's positive, then it's negative, and then it's positive again. What does that mean for the function f? Well, it means up until this point, the function F is decreasing. In this interval, the derivative is positive. It's above the x-axis, so that means the original function F is increasing. Between this point and that point, the function f prime, the derivative, is negative, which means the function f is decreasing. Positive derivative means that the function is increasing. So here we're positive, so it's increasing. Again, since f prime is negative, below the axis, decreasing. Since f prime is above the x-axis, f is actually increasing. Since f prime is here negative, f is decreasing. Since f prime is positive in this interval, f is increasing. So what does that mean for the max and mins? Well, if f is decreasing here and it's increasing here, it means it must have bottomed out at this particular point. So this is a local min. This point corresponds to a local min. Here, up until this point, we're increasing. So we're going up. After this point, f is decreasing. This means it must be a maximum. Local maximum. Up until this point, f is decreasing. We're going down. After this point, we're going up. We're increasing. So this must be a local min. So we've identified 3 local mins and maxes. The first one is a local min, decreasing, then increasing. The next one's a local max, increasing, then decreasing. And the last one is local min, decreasing, then increasing. So that concludes our introduction to how to find local maxes and mins given the graph of the derivative.